We're going a little bit farther into copper piping and tubing. So we're going to look at measuring, cutting, and bending copper tubing and the proper ways to work with copper. The objectives of this section is to explain the tools and methods used to measure copper tubing. We're going to explain the tools and method used to cut copper tubing. We're going to describe the tools and methods used bending copper tubing, and of course the different methods used to join copper tubing. There will be a performance test in this section, and we're going to basically look at how to select the proper personal protection equipment, the PPEs, for working with copper tubing, and how to correctly measure, cut, and join copper tubing. We have a warning, and this is a safety focus. Before you begin a job, think through the potential hazards and wear the proper PPE, including but not limited to safety glasses, a hard hat, gloves. In addition, beware of any hair creams or shaving creams which can be flammable. Always make sure you have quick access to a fire extinguisher on the job. In other words, know where it's located and know how to use it. Now, again, we talked about measuring things before, looking at plastic piping, other piping. It doesn't change for copper tubing. It is extremely important to measure tubing carefully. Several methods of measuring copper tube include end to end, end to center, center to center, end to face, face to face, face to back, center to face, and end to back. And those are the most common that you're going to, well, these are the different ways to measure, and we're going to look at it a little more deeper. So to cut tubing, we use a tubing cutter, and it's a device that has a cutting wheel and has rollers. The rollers allow the tubing to turn easily, while the cutting wheel will basically separate the pipe. It will separate the pipe into different ends. So it's a handheld tubing cutter. It makes a cleaner joint and leaves no metal particles in the pipe. So we don't use a hacksaw. Can you use a hacksaw? Yeah, but you're going to have a lot more issues. A hacksaw is not going to make a very straight cut when a tubing cutter will. Second thing is that a hacksaw will leave burrs which can get inside of the pipe, and if you got burrs inside the pipe, you end up clogging up valves or orifices that can restrict the flow of water. And to use the tubing cutter, I will have a video showing how to do it, so you can see actual things instead of just pictures. But basically, once you mark the tubing for where you want to cut, you will adjust your cutting wheel onto the surface of the pipe. You do not over tighten it. You do not over tighten it. If you do, you can put a rim on the inside of a burr on the inside of the tubing. Of course, you're going to have to remove it. And the bigger the burr, the more time you are wasting trying to close it up. So again, and then when you're cutting, you make the way I do it, I make a couple revolutions around. Then I tighten up the cutting wheel a little bit more. Not a lot. You don't over tighten it. And so I usually make about between an eighth to a quarter turn as the most, an eighth to a quarter turn to tighten up that cutting wheel on the piece of pipe. And then once it cuts through, you have to deburr the inside of it. Most tubing cutters come with a deburring tool attached to it. It works fine. However, there's other deburring tools that works better that you can purchase that will speed up that process of deburring and do a cleaner job, in my opinion. Matter of fact, a pocket knife works really well. So that's something you may carry with you all the time. So if you got a small pocket knife, you can use that to take that burr off the inside of the pipe. But here's one thing to remember. When you are deburring it, make sure the slivers of that copper metal do not go inside of the pipe. Make sure you tap it out. To cut larger size drawn tubing, um, you say you can use a hacksaw, but they do make larger tubing cutters. If you don't have one, you can use a hacksaw, but you got to keep it straight. If you have to use a hacksaw, use the finest blade possible. A hacksaw blade that have multiple teeth, the highest teeth number as possible, so it doesn't make a rough cut. The more teeth per inch, the smoother the cut would be. And the second thing, to make sure you cut straight, you could use a miter box, and that miter box will hold the blade of the of your um, of your hacksaw and keep your pipe straight at the same time, and that way you'll be able to make a very straight cut. And then of course you're going to have to deburr it. Okay, so like I say, more teeth per inch. 32 teeth per inch is probably what you're going to be looking for. Something in the 20s is going to be rough, and if it's in the teens, forget it. You're going to struggle, struggle cutting it, and struggle trying to clean it up. Avoid leaving saw cuttings inside of the tubing, the burrs. File the ends to produce a smooth surface, and carefully clean the inside of the tubing with a cloth. To cut large quantities of tubing, use a portable power tool with a abrasive cutting wheel to cut, clean, and to deburr the tubing. So they do have tubing cutters that you can use, a machine that you can do to be able to cut quickly. Matter of fact, for large pipes, if you use a machine, that would save a lot of labor time. However, you can typically use a tubing, a pipe vise, and hold the pipe, and use larger tubing cutters to do it. Um, Bending tips. Um, Again, the bursting strength of bent tubing is greater than of regular tubing. Here's the reason why. When you're bending copper tube, it will actually help anneal the pipe to harden it even more. It becomes a very strong. Matter of fact, once you bend copper tubing, soft tubing, it actually becomes hard, very hard. And it's even hard to rebend it. So once you bend it, and make sure that you're bending it correctly, because you will not be able to rebend it without distorting the pipe. So bending reduces the number of joints and fittings in a plumbing system, which is good for one reason. It's saving you money not buying fittings. The second thing is a smooth surface. Instead of having a fitting that can have ridges in it that can help reduce the flow rate, but especially smaller tubing, using a bender is always preferred. Always preferred. So when you are using soft tubing, it is best to bend rather than to cut. Again, it saves you time, it saves you money. It's a smoother flow through the pipe. The benefits is great when you are bending smaller tubing, especially when it's soft tubing. You can easily bend smaller diameter by using your hand if you like, but you can buy yourself an inexpensive tubing bender that would handle 3 different sizes of tubing. For example, quarter inch, 5/16, and 3/8. They make a tubing bender that would handle all 3 sizes. Anything larger than 3/8, they usually have separate type benders. And if you do a lot of work, especially like refrigeration work, air conditioning work, where you work with soft tubing all the time, is makes sense to buy yourself a bender. Matter of fact, for larger tubing, I have a bender that comes with um, interchangeable shoes that can go through multiple different sizes. And so I use those instead of using fittings many times. Of course, to learn how to bend correctly and make sure everything fits right, it takes practice. So take care not to flatten the tubing with a bender. So one way by doing that is actually using the right size bender for that tubing. If you don't, it will distort it. One of the worst things you can do to copper pipe is to crimp it, because that crimp becomes a resistance in that piping. Now this is a simple, what we call a spring bender. It's inexpensive, and basically it's a spring that you slide over the tubing, the soft tubing, not rigid tubing, not hard drawn tubing, but soft tubing. And you slide over the tubing, and you will end up using that spring bender. They come in different sizes. They would be sized for that particular size of pipe. So they make one like say 3/8 or ½ inch or 3/4 or 1/4 inch. They make benders for those sizes. You can buy a whole set of them, and so it's an expensive way when you're getting started to use to help bend copper tubing. So you slide it over, then now you can bend the tubing by hand without crimping the pipe. So you can place the tubing bender springs on the outside of the tubing to prevent it from collapsing when you are bending it by hand. These are the mechanical benders. These are different brands and different sizes of benders. The one at the very top is for a very large pipe. The one on the bottom left, that's a common type of bender, and the one on the right side is a combination bender. That's the one I was explaining that would have 1/4 inch, 5/16 and 3/8 sizes on that one bender. One thing about common to all these benders is that it has a specific radius based on that size of pipe. And so one thing you need to know, especially when you're trying to do precision bending, is know what the radius is, because that radius becomes your take up. And so when you want things to fit perfectly, you would consider the radius of those bends from the bender. Soldering pipe is how we join pipes together, and we explained in the other video that soldering is taking another alloy and which has a lower melting point, and we will heat up the pipe and allow that solder to get pulled into that joint, and that joint with that pulling in effect is called a capillary action. It gets sucked into it and fills that cavity. The cavity is very tight. Matter of fact, the cavity space, it's so small, there's no play in that pipe, but it actually, the solder will flow in. And to actually heat it up, we clean the tubing up very well by using sandcloth or a wire brush, and clean it up to remove any oxidation off the pipe. And then the second process is adding a flux to the piping. The flux is some type of barrier, and usually some type of acid, mild acid. It's not going to melt anything or hurt you, but that flux will basically put a barrier on that tubing while you're heating it to keep oxidation from happening. And so that flux allows the solder to adhere to that joint and on the inside of that joint. So we actually put the flux on the male end of the that tubing, and we also put it on inside of that joint of the fitting. So we clean both of those pieces, we flux both pieces, And then we actually join them together, heat it up, and then add the solder and let the solder melt into that fitting through the capillary action. So always use lead-free solder. Here's the reason why. For years they used lead in everything and the water pipes. And then when they discovered that lead caused issues with our mental health, they stopped using it. I'm old enough to remember when they actually mandated it not to use lead solder any longer. So you cannot find it. Oh, I guess you still can find it for other uses, but when it has to do with um, consumable or potable water, which is drinkable water, it is not used at all. Always use lead-free solder. Flux should be lead-free and water soluble, that you can use a wet rag to clean off the piping once you're done with it. Matter of fact, cleaning up the pipe is one of the steps of the process to make sure you are finishing the job correctly. We just don't solder and just walk away from the pipe. We clean the pipe up by using a dry or wet rag to remove any additional flux that was on the pipe, because that, again, um, that flux, let it stay on the pipe, it will start corroding the pipe, it can oxidize the pipe. The heat required to solder is around 350 degrees to 550 degrees. That is lower than the temperature, the melting point of copper. So it depends on the type of solder you are using would be its melting point. And once you get comfortable working with solder, you know how much heat to add to it. One thing we do not want to do is overheat the pipe while you're soldering, because if you overheat it, you can burn the flux, and once you burn the flux, the solder will not stick to it. It will not stick. So use sweat joints with hard or soft copper with nominal sizes from 1/8 to 4 inches. There are some of the tools that you would use when you're soldering. From left to right, we got a tubing cutter to cut the pipe. We have a torch to bring heat to the piping. We use these fitting brushes. Basically, these are a wire brush. Usually is stainless steel bristles on it. And the two ends are for the inside of the fitting, the inside of the fitting. The two other holes that we see here, here and here, is the for the outside of the tubing. So we put slide the tube through and we just twist it, and it will end up cleaning the outside of it. However, we can use other things like this here. This is sandcloth. This is a roll of sandcloth. We unroll part of it, tear it off, and we can clean up the surface of the tubing. It's better to use a brush on the inside of the fitting. It can do a better job and takes less time than trying to use sandcloth. But can you clean it with sandcloth? Yeah, you can. You can. This is the solder. It's a roll of solder. This is the flux in a little container, and these are flux brushes. So we use a brush to dab on some of the flux onto the brush end, and we brush it inside of the fitting cleanly and neatly, not putting too much because we don't want the flux running inside of the piping. And then we do the outside of the tubing, so it can actually coat both sizes to keep it from oxidizing while you're heating it up with a torch. Okay, and it's a process of, I just went through the process again, I'll go through it again. So when we're looking at the soldering process, is always, once you cut it, you're going to clean. You're going to clean inside of the fitting, and you're going to clean outside of the pipe. This picture here shows you a very clean surface. You can see you can see the oxidation on the copper tubing, but you see the very shiny clean. And all that took is just using sandcloth or a wire brush to clean it up. We clean both the fitting and the tubing. And then we could add flux to it, putting flux on the inside of the fitting. Then we also do the outside of the piping too. And then we add the torch. We bring it to the right temperature, and that's what the practice come in. It's just not just adding heat to it, it's the right amount of heat. And so we don't melt the solder with the flame, we melt the solder with the temperature of the tubing. The tubing would melt it. So that means the torch is heating up the copper tubing. We got to bring it to the right temperature. And it takes practice, a lot of practice. It's just not going to come very easy. It may be able to do it easy time to time, but there's a lot of you need to learn in different positions and looking at the different thickness of the tubing because of the type it is, how much heat you need to add based on those considerations. So again, adding heat to the fitting, adding some heat to the tubing, getting at the right temperature, both at the right temperature. Then you can add your solder to it and allow it to flow around. And you can watch it. Once you add it to one spot, if the temperature is correct all the way around that fitting and tubing, that solder will flow all the way around. That capillary attraction will pull that solder completely through that fitting. Then once it cools down, then you can clean up your tubing. Take a damp rag and wipe off any extra flux off the pipe to clean it up so it doesn't oxidize it. Now this is a compression fitting, and a compression fitting will have, again, I'm going to point it out. This is the fitting is here. This is the compression side. The compression side is always different than the regular threaded side. This is pipe threads. These fittings are strictly for compression fittings. It's a finer thread, so it's not interchangeable. You cannot put a pipe fitting onto this side. It's a compression fitting. So this is the compression nut that fits over the tubing. This black portion is a ring. And this black portion is that ring is the compression, the ferrule. And what it will do, once we tighten up this nut onto the fitting, it will kind of compress it. It will close up and it actually joins to the tubing. It joins to it and it becomes a watertight seal. It will not leak if it's done correctly. If you tighten it up completely the way it's designed to, the tension on it, it will not leak. You don't need no pipe dope. You don't need no Teflon tape on it. You don't need any on that compression fitting. It's a metal to metal seal. So creating a compression joint, kind of went through it already, but here's at step one: measure, cut, and ream the tubing. Make sure that the tube is cut square, which is true, very square. So you use a tubing cutter, and it's free of any burrs. If you have burrs on the outside of it, or it's bowled out any type of way, that ferrule will not slip onto that copper tubing. You're going to have to probably cut it off if it is. Cut that end off and just start a new end, because it's designed to fit snugly on that tubing. Number two says, slip the nut over the tubing and slide the compression ring on the tube with the teeth facing the tube end. Number three, install the cone with the convex surface toward the end of the tubing. Now, some compression rings or ferrules is the same on both sides. Some might be flat on one side with the taper end on the side. In other words, the taper side will always be facing the fitting. the fitting, not the the compression nut, but the fitting that you slide in the tubing in. That taper end will always be facing that way. So install the cone with the convex surface toward the end of the tube. To be sure that the fitting goes together completely, make sure that a 1/4 inch of the tube extends beyond the cone when working with a 1/2 inch tube, and that the 1/2 inch of the tube extends beyond the cone when working with the tubing. But let me explain something. If you slide it in the copper tubing inside a fitting, it will compensate for that point for you. So you don't have to worry about it. Just make sure you slide that tubing inside of the fitting till it stops. If you do that, it will be in the right position. So the fourth says push the nut onto the fitting. So you slide the nut toward the fitting, make sure that the tubing is inside of that fitting completely, and then you can start to tighten, and then use a wrench to tighten it up. Use a wrench till you put the correct torque on that nut. And then if you turn the pressure on, it will not leak. It will not leak. If it leaks, it's meaning that you need to tighten it up a little bit more. Creating a flare joint, again, you need a flaring tool. There's no way possible you can make a flare fitting without the flaring tool. So flare joints may be required, and an installation in which a fire hazard exists and a torch for soldering or brazing is not permitted. So in locations where you don't want to add a heat that can damage something, because of course using a torch, you may end up burning something. So a flare fitting will be an area where you don't want to add heat to, let's say, a device, a valve or something like that. So in refrigeration, they use flare fittings quite a bit because they don't want to damage the components or the valves or things that you need to connect. So in a flare fitting, like I said, it is actually the tubing is sandwiched between the flare nut and the flare fitting. So what you see here, at this point here, this is the top of the flare tool. So this yoke here, this yoke goes around the flaring block. The darker color, the black thing, is the flaring block. This is the flaring yoke. It basically, this flaring block is holding the tubing, and that tubing, once you tighten this flaring block down, it will keep it in place. Then we slide the yoke over it, and then we turn this knob here at the top, this handle at the top, and it would actually screw down to flare the copper tubing outward. And so inside of this flaring block, it is tapered. It's tapered like at 45 degrees. And so when this flaring tool that's part of this yoke comes down, it will, of course, we are flaring soft tubing. Soft tubing is not rigid. You cannot flare rigid, hard-drawn copper. It will split the pipe. But soft tubing you can. So here's the steps. Step 1, measure, cut, and ream the tubing. Step 2, slip the flare nut over the tubing. Step 3, use the flaring tool to flare the tubing in until the fit is perfect. In other words, that tubing should extend beyond that flaring block about the thickness of a nickel or a quarter, and depending on the size of the tubing. So again, if it's very small tubing, about the thickness of a dime, the flat side of the dime. If it's a larger, maybe a nickel, and if it's a quarter rather, and if it's very large, maybe a nickel. We're talking about a 1/16 of an inch. We're talking about maybe 3/32 of an inch, 1/8 of an inch, depending on the size of the piping. So we actually play around with it until we get it the right point, then we could flare it. So slip the flare nut over the tubing. 3, use the flaring tool to flare the tubing end until the fit is perfect. 4, slide the nut until each end of the flare tubing. Gently bend or shape the tubing by hand over the male threads of each fitting. Then 5, it says use a smooth jaw adjustment wrench. In other words, this adjustable wrench to be able to tighten the flare nut until the fitting is snug. Then test it. Pressurize it. If it's leaking, if you made the flare correctly, all you need to just tighten up the flare nut just a little bit more. Of course, we use hammers. So the next thing it's not a flare fitting, but we call it swage fittings, and we use a hammer to do it. So they say flare fittings, but it's a swage joint. And basically, we use this in the place of a coupling. A coupling, is used to joining 2 pieces of pipe together. But we can actually swage the inside of one tubing, the same size of the tubing, so you'll be able to slide your second piece into it. In this case, you're actually saving yourself money on buying couplings. So this is a swage joint. Again, this end here been swaged by sliding a swaging tool and then using a hammer to hammer that swaging tool inside of the opening, the inside diameter, to expand it to be this size. Then after that point, you can sweat your pipe. And again, if you can join a piece of pipe together like this, you just save some costs of adding a fitting. Some terms: capillary attraction, the process during soldering in which the molten solder flows into the narrow gap between the pipe and the joint, regardless of whether the solder is flowing up or down or horizontal. That's the cool thing. When you heat it up correctly, that capillary action of pulling it into that fitting will go in any direction. You can solder upside down. It can suck it up into the fitting. You can do it sideways. You can do it straight up. So drop forge is the characteristics of a product made when heated metal is pounded or shaped between dies with a drop hammer or a press. In other words, something is hot, they use a hammer to beat it. It's actually causing the molecules of that metal to join together in a certain way. And it's they use for tools and things like that in the hardening process. Sizing, a sizing tool is a tool considered of a plug or a sizing ring that is used to reshape the form pipe back to the roundness, and it's similar to a swaging tool. Matter of fact, you can use a swaging tool if you got a pipe that's bent to one end, that we can use it to help straighten it out some. To measure the full length of a line of tubing, plumbers use and what? To measure the full length of a line of tubing, plumbers use an or a blank. End-to-end measurement, face-to-face measurement, center-to-center measurement, or back-to-back measurement. It's end-to-end. So you want to know the length of it, end to end, end of one piece of pipe to the end of the other piece of pipe. Face to face is looking at the fittings. The end of the face of a fitting to the end of the face of a fitting. Center to center is looking at the center of the pipe, of the fitting rather. Center of the fitting, not the pipe. And back to back is measuring the outside of that fitting. The blade of a hacksaw used to cut drawn tubing should have blank. 10 teeth per inch, 14 teeth per inch, 24 teeth per inch, 32 teeth per inch. When it comes to cutting tubing, if you have to use a hacksaw, use the largest um, teeth per inch as possible. And 32 will be that number, unless you can find something higher than that. 32 teeth per inch. It will give you a smooth cut. I think that's a mistake there. The blade of a hacksaw. But anyway, 32, the higher the number, the best. If you have to go with a 24, it will cut. But if you use a 32, I promise you, you will have a better cut. It'll be a cleaner cut. 24s are certainly easier to find than 32s because a 32, because usually hacksaws are used for cutting hard things like steel pipes and things. But you can use it for plastic. And the softer the material, the smaller the teeth per inch you can use. The harder the metal, the more teeth per inch you should use. But when copper, to make a clean cut, the higher the teeth will be better. When using a mechanical bender, the minimum bending radius of half-inch drawn copper tubing is blank. Of half-inch drawn copper when using mechanical bender. Now, if it's drawn copper, I'm going to explain something after we go to answer. The answer is 2.5 inches. 2.5 inches. It's a large radius for a half inch. That's a large radius, long sweep radius for a half-inch drawn copper. Number one, because it's hard copper, you can actually crimp that pipe or damage it. But in this case, what we need to do, if what I was going to explain earlier, if I was going to bend hard drawn copper, I would actually heat the pipe up first to anneal the pipe. Because if I take hard drawn copper, if I put a torch to it, it would separate the molecules. The molecules would separate. Then I let it cool down. Then I can bend that pipe easily. It actually becomes soft tubing. Now, after I bend it, it will harden back up again. And I could use a smaller radius if I have one. But if it's larger pipe, you will use a large radius there. And try to use a large radius anyway when you have to deal with flow rates, because the larger the radius, the least resistance that fitting will have. Question number 4 is that the type of joint that can be safely made in a fire hazard environment is it a flare joint, solder joint, braze joint, sweat joint? Now, B, C, and D all uses a torch. A torch. B, C, and D. Solder joint is using soft metal. A braze joint is definitely using harder alloys for very strong joints, but you use a torch in even higher temperatures. A sweat joint is the same thing as a solder joint. So it's a flare joint is the answer, a flare joint.